Hey guys, welcome back to SaxSQL. My name is Ferry, and today we're going to look at what data attributes we will store in a database and which data attributes will not be stored in a database. We have looked at the phenomena of what data is, and we also explored in our last videos what a database is and what the difference is between structured and unstructured data. So from now on, we will focus on structured data. And as a recap, structured data is technically all the data you can put in a list. So if you can enter it in a list in, for example, a spreadsheet like Excel, we consider it data. That includes media files, audio, pictures, and video. Today we will focus on text data. And by using an example in the form of an address sticker, we're going to analyze the data items that are used on the address sticker in order to decide if that data item ends up in the database or not in the database. This is a technique called data modeling. This is one of the techniques you can use to model data. And this technique is called bottom up. So you start to reason from data items, so very specific items of data will be analyzed, as opposed to what is called a top-down approach, where you look at the world and you try to design a model that technically is based on how we interact with each other in the real world, and we derive the data items based on that model. So that is something that we will discuss later on in this course. We start to design a database from the level of what is called an ERD, an entity relationship diagram, and where we identify the entities that act upon each other in the real world. For example, customers, products, and orders. And we then identify which data items are needed in the database for those entities to be simulated in an information system of which a database is a part. So that might sound a bit complicated, but in order to understand these different approaches, it's best to work once again from an example. So today, bottom up. Therefore, we look at the output of an existing system or a report that you want the database to be able to print or to be put on screen for the end user, and to see what kind of data items we will find there and how we are going to deal with storing them in the database. Okay, I will see you on the other side. Welcome to SaxSQL. This is episode number 4 on databases.
Hi, this is Ferry, your data expert. Welcome to SaxSQL.
Okay guys, welcome back in this first whiteboard session of this video. Before we dive into the example that I mentioned before, the address sticker and analyzing which data items are on the address stickers and how we are going to identify which data we're going to store in the database and which we will not, we first need to go back to discuss a main concept in computer systems in general, and that is the concept of what I call IPO. IPO is short for input, process, output, and every single computerized system that is comprised of hardware, software, an end user, database, and other different components technically work according to these 3 stages. There is a part that deals with input, mostly from interaction with the interface from the end user perspective. Then a processing part, the decision-making part, usually software in combination with hardware that processes the input. And then the output, which is the result of the action invoked by the end user via the interface, that then leads to output of a computerized system, which is in a lot of cases either information shown on the screen, or, of course, reports printed on a physical piece of paper via a regular printer, an office printer, for example. And that report contains information that is then used by the end user to either make decisions or pass on to a manager, and that manager is going to make decisions. And via that system, that IPO, input process output, we can determine what the exact need is of the end user. So what kind of reports and what kind of information is the end user expecting from the computer system. And that will determine what data need to be stored in the database in order to support that flow of output. So let me start with a very simple breakdown of this concept, and therefore I return to the physical whiteboard. So the concept of a computer system in general, or what we call an information system, IS, which is technically an overarching term for any computerized system comprised of hardware, software, data, end users, and procedures, which main goal or task is to support an end user, a human being, with his or her daily task. For example, an accountant using accountancy software in order to do the accountancy activities, the accountancy tasks. And the second main goal is to fulfill the information need of the end user with the correct information at the correct point in time. This is also called JIT, just-in-time information. Now, that sounds very simplistic, but when you start to think about it, in order to guarantee that information comes out correctly and in time, this is actually quite complex in terms of how you would set up an information system like that. Because everything depends on the database which stores the raw data that then can be altered or retrieved in order to facilitate the technically the information system to supply that information need. Now, a lot of big words, but let's keep it extremely simple. The three stages that we identify in computer science in terms of information systems are input, process, output. Now let's return to that example of that accountant, right? And the accountant has an information need, and that information need in this case is just a very simple list of all the transactions for customer X. Let's call him Joe. For customer Joe from the last month. We just need to be able to look up customer Joe in this accountancy information system. The accountant needs to be able to sort the transactions per date. It needs to be limited to a certain time frame, last month. And then it needs to be able to print this list on the office printer that the accountant is working in. Now, the information system, of course, contains that database, and the database sits here. Let's draw the same symbol as we have seen before when I discussed what a database is. It's technically a cylinder, and we just call it DB, which is technically just a large container, a structured container with all the data that the information system can access. So the database contains all the client information, transaction information, debit information, technically every piece of financial data that is needed within the accountancy application to be accessed by the accountant at any point in time and altered at any point in time based on what task he is working on as an accountant. Now, of course, the accountant himself or herself is on this side. That's an end user who provides the input to the system, the information system that he or she is going to use. So I'm going to call this the accountant A, C, C. Now, I'm not going to draw all the components of this information system, but we're going to keep it extremely simple. The output of the information system in this specific scenario, and once again, a list of transactions for customer Joe, needs to be a printed form. So let's just draw a physical printed report here that says Joe. So this is a physical piece of output that can be picked up from the printer, where all these lines here present the transaction overview of customer Joe made in the last month. So the question now becomes is, if the accountant interacts with the information system, it needs to be able to interact with an interface, which is technically that part of the software that you see on screen. So again, let me draw the interface here. All right. So let's reconnect. That was a bit of a delay. Okay, this doesn't go. Okay, so that delay, not sure what it was, but let's keep going. Interface. Now, the accountant will technically use a keyboard and mouse to look up customer Joe. Then it will use a filter, probably in the interface, that then says, okay, give me all the transactions for customer Joe, the information need for the accountant for that month. So what will happen in the processing stage here? So once that input has been specified here, what will happen in the processing stage, IPO, input, process, output? Yeah, technically, and this is of course a bit oversimplified, what happens is the computer itself and the software, the accountancy software, will take that request from the interface, and eventually at some point in time, the software will connect to the database, which again stores all the data that is relevant for the accountant. So that means all the transaction and financial information for all the customers that the accountant has. And the software will query the database using SQL, which we will discuss later, and look up customer Joe, and then retrieves all the data related to customer Joe. And on top of that, in the same database, make sure that all the transactions for customer Joe are also found. That data is retrieved from the database. The software will process it, and then in the processing part, eventually there will be a request sent to the printer, and the printer will print that data in a certain format, the report format, so that the printer can actually print the data, and that in this case turn into information, because remember, information is data in context, so the end user can make a decision, which is in this case the transaction of customer Joe that are important for the accountant to be printed, only for customer Joe, not for any other customer, and only within the last month. That's the information need. And then this report will be printed. Yeah. Now this is in a simple format how an information system works. So the challenge here is okay, if we want to print Joe's transaction reports, then we need to design a database that holds the information, technically data, because when the data is stored in a database, it will only turn into information after the software processes the data in such a format based on the request of the accountant that the relevant data is used for the information need of the accountant. And relevant data in context becomes information when the accountant is making a request for that specific information to be printed. In this case, Joe's record with all the transactions from last month. Yeah, but remember why we are here. We are determined to design a database, so this component that allows the accountant to print this report. So one of the basic questions that you need to ask yourself is, okay, how do we determine what kind of data we store in the database? And that is what we need to discuss in the next 2 or 3 videos. So what data items need to be stored in the database in order for the software and the accountant to be able to print this report. Now, you can obviously clearly say like, well, Joe, which is the name of the customer, is stored in a database. But what kind of data do you want to store about your customer? Only Joe? How many Joes are there? So is it Joe Smith? Where does Joe Smith live? Oh, in Los Angeles? Or in Amsterdam? Or in Rome? Or maybe there are 2 Joe Smiths, and how do you distinct them? What about the financial transactions down here? What kind of data items do you want to store there? Maybe the amount that has been transferred from one account to the other. But what is account data? Is that just an account number, or is that an account holder's name? The date that the account was opened? The kind of account, saving or checking account? All these are data items, and all these need to be stored in this database in order for this report to be able to be printed. Now, what we're going to do is we're going to, in the second part, or in the last part of this video, we're going to make sure that we understand that how to identify the data items for this database, in order to facilitate this process here. And that's harder than you think. Now, of course, we're going to work with a way simpler example than Joe and his transactions list, because this is very complicated. We're just going to look at a system that can print address stickers. So you need to store people's addresses. But even that already requires what is called data modeling. You need to model what data items go into the database and which are not, and which ones can be derived. All right. Okay, see you on the other side. All right, guys, welcome back to this third part of the video. As you can see, I pulled up 2 address stickers, and we're going to use these to analyze which data attributes they contain and how we're going to identify them, and then also determine if they are suitable to be stored in the database and the reasons why or why not. Now, this is a very important process, because even though it looks simple, there are quite a lot of things to take into account when you identify attributes and when you decide if you should store them in a database or not. Remember that a database is a reflection from reality. So we expect the data to be stored in the database to reflect reality, and what that means is that the integrity of the dataset cannot be compromised. So the integrity of the dataset technically means that every time an end user interacts with an information system and we hit the print button and a report comes out, that we should be able to trust that report as being reflected, a reflection based on what happens in reality. So what that means is that the information on the report, based on the data we pull from the database, needs to be reliable. And why is that? Because we make decisions based on those reports. Now imagine that, I don't know, let's place an order. Somebody prints an order list, and that order list doesn't contain all the products you've ordered. That has huge implications for maybe the logistics, the payment. Maybe you get a product for free because it wasn't on your order list. Maybe the packaging department didn't send you the product, but the financial department billed you for it because the packaging list was wrong. Had all kinds of far-reaching implications that can even go as far as people's life in jeopardy. That sounds a bit extreme. Just imagine your medical data being faulty in the hospital database, and that the doctor you're meeting for your next prescription is going to make a decision to alter your prescription based on the wrongful data in the database of the hospital. Now, you don't even want to think about the consequences of a situation like that. We rely on computer systems and we rely on the data being correct in the database. So when you are a database designer, you need to make sure that you identify the correct data attributes and that you store them in such a way that people can trust your database design. That's a huge responsibility. Now, of course, this is a very complex process in reality, but in order to understand the conceptual idea behind this, we just work off a very simple example. This address sticker is a report. This is the same as a package list or receipt or a bill. It contains printed text. That's all. That's what a report is. And the printed text can contain visual items like a logo or a picture or colors or background colors. All that we will ignore for now. You can see in this case we have two address stickers, but technically they contain the same data. How do we know? Well, we can identify, first of all, the name of a person. Then the second line contains a street name, at least that's what it looks like, with a unit number or a house number. And then the third line is, as I can identify, an American address containing the city or town, the state, and the zip code. Now, even though these stickers look very different, they contain the same data. For a database, that is the most important thing. So which data items can we identify in these examples? So we're going back to the drawing board. And what I'm going to do is I'm going to analyze every single piece of data we see. Now, the first thing we need to do is, and we have two address stickers, is to see what general format you can recognize within these two examples. And as I've just said, the first thing you can see is that our data analysis will start off with that there are 3 lines. So technically you can derive 3 lines of data. The first contains the name. Let's make this a bit more clear. The second is a street. And as you can see, I'm already struggling with finding the right name of the data attribute, because you can say street, but then what about the house number? Well, you can also call it address, but what is an address? Doesn't an address also contain the zip code and the city? Is that a full address? So the first thing you notice here is that there's the ambiguity of language, and that is a big problem, because when you design a database, which is again a computerized environment, you need to be very specific in the words and labels you use. So even though this looks like a theoretical exercise, it's not. What you make here is what is called a conceptual design that eventually will be used to create a physical design, and that physical design is the blueprint for your actual database. Now, in normal English, the names of the data attributes that you write down here will literally be used in your physical database. If the name is not clear, the database design will not be clear. And if it's not clear, then it's more prone to ambiguity. More prone to ambiguity means that people don't really know how to use it. Because if you say street, what do you mean by that? Yeah. Is that a full address? Is that including house number? Is that a street just only the name of the actual street, or etc.? Yeah. The last line is, how do you call this? Well, you can already see we have a problem here with the third line. The third line is comprised of at least 3 data items. It's not just one data item. How can you recognize that? Well, first of all, there's city, and then state, Michigan, and these numbers represent the zip code. How do I know this? Because I recognize this as an address object. Because this is an address sticker, I'm going to identify every individual part and give it a name, so a data attribute, a name that identifies that unique attribute. Now that brings us to the next concept, and that is that data attributes need to be atomic. Atomic means every single data attribute needs to represent one kind of data. You cannot say address. Address is not atomic. Address is a composite data attribute. Composite means is made up of multiple components. So you need to identify not only the data attributes that are present here, but you also need to make them atomic. So let's try to do that. Name, street, city, Lancaster, right? That's a city. Now for the second address sticker, of course, these attributes are the same. Miami Beach is a city. Then MI, which is Michigan, what is that? That's a state, right? State. And zip code. So what we have done here is identified 5 different data attributes. Now, even though this looks good on the surface, this still has issues. Now, the first thing we can see is that name and street are still composite data. They still contain other attributes in itself. They are not atomic. And why is that? Well, look at the name. Tom and Nancy Baker. A name is comprised of a surname and a first name. Now in this case, even 2 first names. If you want to send a letter to the Baker family and you want to automatically generate a letter that contains Dear Nancy Baker or Dear Mrs. Baker, then the database need to be able to identify Baker as a separate data item. So if you store the name as Tom and Nancy Baker in the database, then every time you request the name of this person or this family from the database, you will get Tom and Nancy Baker, because you store it at one. You can compare this to going to the shop and you want to buy a can of Coke, but you buy a 6-pack instead. Even though you have to buy the whole 6-pack, you can still take out the can of Coke, but you only technically want the can of Coke as a solo item, an atomic item. So in this case, we treat data items this way. We identify from a data analyst position that the Baker surname is a different data item than the first name of, in this case, this couple. So we can make a choice. We can make this composite data name, we can make this atomic name, and this is the way we do it. We divide this in, first of all, surname, and first name. Now, surname and first name are atomic. Then you can make the decision if you want to store Tom and Nancy as 2 different individuals in the database, or Tom and Nancy. So you have a person in your database that is Tom Baker, you have a person in the database that is Nancy Baker, or you have a family in the database that is Tom and Nancy Baker. And that depends on what the database is used for. That is not an arbitrary choice. If the customer is the family Baker, so you treat that as one unit, one entity, then Tom and Nancy Baker will just be one family in your database. So that what that means is that the surname Baker and the corresponding first name will be Tom and Nancy, and that's fine. Yeah. But if in the future Nancy Baker will make a separate order from Tom Baker, then the database should be able to account for that. And in that regard, then you should make sure that Tom and Nancy Baker can also be entered as separate entities, which means that the first name should account for Tom only or for Nancy only. Yeah? So these are the kind of questions you need to ask yourself. And you cannot just make a random choice. You cannot make any assumptions. What you need to do is you need to identify this with the domain. And what that means is that you need to ask the company you designed this database for on how they want to use this database. Is it okay if a full family name is used or a couple's name like this? Is that atomic for their users? Yeah. Now the same goes for the street. Street is not atomic. Street is comprised of street is comprised of, as you can see, a house number or unit number and a street name. So street name, street number or house number. Again, the names of these attributes is what you decide. Yeah. Now, what you see here is data modeling or data analysis, and it comes down to looking at the data at a very detailed level, identifying which data attributes are there and which data attributes are stored in the database in what way. And the most important thing is to identify atomic data items. If you want the database to be able to print a list of all the orders placed by people with the surname Miller, then you need to store the surname Miller separately from the first name. So it is really depends on usage, but also efficiency, as we will later see. So let's do a short recap of this exercise. So what can we conclude from this? Let's clear this screen and let's empty it out. So in summary, based on just this address sticker, we have selected the following data items, data attributes, which is the same thing, kinds of data for the database. One is surname. Surname. Then first name. That's by choice. Just one first name. And first name can contain two names. That's what we decide. It's not a good practice in general, but in this case we just make the assumption that and verified with the domain that this is okay. Then we have street name or street, which is the name of the street. Street. House underscore number. Now, what's up with the underscore? Make sure that there are no spaces in the name of data attributes. That is a kind of convention that we use in database design. There's a technical reason for that we will explain later on as well. Then we will have, you can write city, you can also write hometown. That is what you can choose as well. I'm going to keep it simple. City, state, and the last one is zip code. For every single customer, I'm going to store the following data attributes in the database: surname, first name, street, house number, city, state, and zip code. Now you might ask yourself, yeah, but what about phone number? What about email address? How do you contact these people? Well, what you need to realize is that in reality, these two address stickers are not the only output of an information system. So these address stickers contain data attributes for that particular output. Of course, there are multiple reports used in systems. For example, if you have like a financial system, then you have different financial reports being printed. All these need to be analyzed and need to be used to identify these items. So maybe there's a customer list that is used by the same company on top of this address sticker, and that customer list contains email addresses and phone numbers. Then you add the two items in here. The goal is to identify all these data attributes, data items, based on all the different kinds of outputs that are being used or want to be used based on what the company wants. Now, another thing you need to keep in mind here, and that's where we stop for today. It's a lot of information already. Is that if you look at these attributes, they clearly identify a person or a family, right? But you also need to keep in mind that if you store what is called an entity that is related to a person, and an entity is an object in reality, an actor in reality, in this case, a customer, you need to realize that there also might be a different actor that is also a person. For example, in a regular trading company, you don't only have customers, you also have suppliers, or you have employees, and their data is also stored in a database, right? And employees have a surname. Customers have a surname. Suppliers have a surname. So how does the database know if this surname is related to a customer, an employee, or a supplier, or a shipper, or any of these people? So what we usually do is we already start to identify what kind of entity these attributes relate to. So you can do this like as follows, by renaming these attributes like cost, customer, underscore, surname. Yeah. That is the surname of the customer. And you can then also store things like cost underscore first name, emp or employee, or abbreviated emp underscore first name. So that means that you're already going to take into account the kind of person these attributes refer to. Now, there is a different way of doing this, which we will discuss later, but this is something you need to be aware of. Yeah? When you design a database, you have a variety of actors, and when you use a variety of different forms, usually that form is used by, or report is referring to one actor, one entity. Yeah? So in this case, all these attributes are related to the customer entity, cost, as a prefix to all these attribute names. Yeah. Okay, so I hope this gives you an idea that even though the example looks extremely simple, it's very important to be aware of the context that these attributes are used in reality, because once again, this process is to support your database design, and the database needs to reflect reality. Yeah. Okay, in the next video, we're going to focus a little bit more on these attributes and the different categories we can classify them in, because we also have to talk about which attributes are actually being stored in a database and which attributes can be derived from other attributes. Yeah? And that is something that is extremely important, because in a database we only want to store data that cannot be calculated, that cannot be derived from other data. Simple example of that is, to do a bit of a cliffhanger to the next video. For example, you have your school report. That school report contains all your grades and also your average GPA. The average GPA is not something that will be stored physically in a database. It will be calculated based on the stored grades. And the reason is simple. If you store it, you need to adjust it. And if you store it, you need, based on additional or changing grades, that average calculation will change, right? So that kind of data will not be stored in a database. That will be derived based on calculations by the software. But in order to do that, we need to identify that as well. Yeah. So we will discuss that in the next video. Thanks for now, and this is SaxSQL out. Thank you very much. Let me stop the recording. Like I said, please rewatch this video a few times. It's not that easy as it seems on the surface, even though the examples look simple. Don't be fooled. Yeah. Leave any comments on this video if you have any questions about these concepts. I'm very much looking forward to your feedback on these videos, and if I need to elaborate on certain concepts a bit more or with different examples, then please don't hesitate to let me know, either by sending a comment my way or the contact information in the video. My website is not up yet, but that will change soon. I hope this has been a useful series so far, and we just keep going until we hit the 20. Soon we're going to dive into SQL as well. Okay, for now, bye-bye. SaxSQL out.
Thanks for watching. Check my other videos to master your data.